Now there's a big item towards the last down, 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 down. Can you see it? It's a big left-hand side. Can we all see it?
Yes, sir.
So that's our incomer. You know, the incomer has the highest rating. Are you here with me? Now, you can see breaker at the top. Can we see breakers? White in colors. Can you see all those breakers?
Yes, sir.
Yes, sir.
Those are the outgoings now. Are you there with me? You can see another big breaker. Those are the additional incomer. Sometimes they might make it in form of outgoings also. Now go downward a bit. Go downward a bit. Go downward, down, down, down. Now, you can see a plate that has a small gear switch, small item like this. Small item. Can we see what a small item that look like a switch whereby you can turn around?
Yes, sir. Yes, sir.
So beside it, there's a bus bar. Beside it, there's a bus bar. So that's the bus bar. Now you can see that beside the breaker now, beside that small bus bar, there's something called a surge arrestor. So that's a surge arrestor. So this is how a typical panel look like. This typical panel is being done by a panel builder. You can't see an electrical engineer because of I'm a certified electrical engineer, I can do it. No. We have different people with different work. Panel builder, what they do is panel. They don't do anything. You can't see them saying, I'm an engineer, I can do this. No. They are panel builder. And whatever electrical engineer design, there might still be an adjustment coming from the panel builder based on the experience he has. Are you there with me? Can you show us that those cables? We have the different type of cables I sent to you. No, please, can you please project the cables for us? I'm seeing many faces tonight. Please project the cables for us so that we can be fast with today's lecture, so that we can both be on the same page. Where is the door? Please be fast. I still have a meeting by 9. Can we be fast about it?
Please hold on, sir. I'm trying to switch.
Okay. Casablanca.
Is this showing now, sir?
Are we seeing it? I'm not the only one online. So if everybody can see it, I will also see it. Hey, I can see my friend Awoshika. You were not online yesterday. Now look
Yes,
at our cable now. Can you see our cable?
yes,
Can you see our cable?
Yes.
yes.
Now
Yes.
this is what they call PVC SWA PVC. Now the reason they call it PVC SWA PVC. You can see that there's an aluminum wire there, Abi. Hello. Can see that
Yes, sir.
you can see there's an aluminum cable. After an aluminum cable, you now see another shielded black before you now
Yes.
see the armored cable in this case now. So you can see what they wrote there. They wrote PVC insulated PVC shielded clearly armored cable. So this is PVC SWA, PVC SWA. Both of them. You can see this one is armored. This one is also armored. Next picture, please. Next picture. So this is a bare stranded copper cable. You can see that this cable at the back is how many? I think this one should be 3 core. Yes, 3 core. Next one, please. So this is a PVC. So single core. Next picture, please. No. Go back. No. To where I'm saying, okay, now, can you hear me? No. It's not this one. It's not this one. Go back. One, yes. Hold on. This is what I want. Can you see your... I'm okay with this one. Can you see our transformer having a plate? I'm not bothered about the plane because that's the civil works already, not M&E work. Now you can see the transformer. Go back a bit. Go back. Do we see where your cables are being run? Go back. No. Go back, please. Or did I not send this drawing completely? Hold on. Let me try and check. Maybe I send this drawing completely. I want to see maybe where they run your cable. But you can't just see that one. Where our this okay. Go back. One more. That cable. I want to see that cable. Hey, you can see what is here now. This is just an LPE cable. LPE cable. Can someone tell me the meaning? Anybody? Hello? Can someone tell me the meaning of this cable? Hello? Don't let us just keep quiet that I'm the only one. No, I'm not the only one doing this thing. Everybody is doing it together. Can someone tell me the meaning of LPE cable and where it's being used?
Hello, sir. Good evening. Can you hear me?
Yes, I can hear you. You were not online yesterday. What's wrong?
Yes, I got home late, so and when I got to my slept off.
Oh, you slept off. Okay, continue.
Well, this according to online, XLP is a cross-linked polyethylene insulated cable.
Etilo cheat. According to online. Oh yeah, tell me where it's being used. That's where we catch you.
For transmitting electricity in low, medium, and high voltage networks.
Hey, continue.
Ah,
Hey, I don't
they,
tell her.
I don't know.
Yeah.
Mm,
Okay, actually, can you repeat the full meaning of that one, SLP? I will tell you.
Cross-linked polyethylene.
Now,
Ethylene.
you see this SLP cable. This SLP cable can never be used in transmitting light from the transformer inside the building. No, they don't use it. The only where this SLP cable is for transmission from your high tension, either 33 or 11 kV, is where your SLP cable is being used. Nowhere is being used. You can't use SLP from your panel into the building. No, because it's a special cable used from where? From your high tension 11 kV or 33. Are you there with me? Are we there? So if you
Yes,
look
sir.
at some designs, they will give you your cable is from SMP cable, is from high tension to cable runs. I will have said that we should calculate your voltage rating, but I will want us to finish this one now before we now move to the mathematics aspect, whereby we now bring in pieces, whereby we be doing power over this. Are you there with me? So we now do a voltage rating, but that voltage rating also is the way that we need to be careful, whereby in this voltage rating now, we must use some cable, and it's different from, how will I call it? It's different from Niger chain. Can anybody give me any other cable apart from those one I just mentioned?
Is it Nigerian cable, sir?
Yes, now. Che, I want to be importing cable. So yeah,
There's Coleman. There's Coleman wire, sir.
I've mentioned Coleman, I've mentioned Niger chain, I've mentioned cable metal. Any other cable that you know is of standard of all these three cables I just mentioned, that you know that is of standard. Nobody is responding. So if I mention another cable for you now, you can't even tell me that you don't know it's not in existence. But let's just put that one outside. So tonight we'll be measuring our different sizes of our cable now. In this cable now, we have to bring in our experience and bring in our what? Our everybody must contribute. Can you hear me? Everybody will contribute. I will start calling names now. Everybody. Bode wa kankan sálọ. You people should run away. Because I know some people here, they will just run away. Pia. So now, can we open to the drawing we used yesterday? I'm looking for architecture drawing of this thing. Can we open to the drawing we used yesterday? Can we open to page 2? Can we open to page 2, please?
Is it the sheet note, sir?
Yeah. I sent a drawing yesterday with a taking of. Can we open to the this thing? And I'm not taking much time on this aspect because I know that if you are able to measure one cable, you should be able to measure the rest. Just like you don't just want to give an idea of what I'm talking about now. Can we open to the okay? Or let me send us this cable, this drawing. So that drawing can be used to establish what I'm talking about now. But I just want to use something easier for us so that we won't be having an issue of this and this and this. Are we on that page? Are we there?
Yes, sir.
So I just want to give us a drawing that we visualize how it's being done. Sometimes not every drawing will be designed like that. No, don't put that one in mind. Not every drawing will be designed like this, but I just want to have a 3D. I just want us to have this 3D of this drawing. Mr. Jamiu. Mr. Jamiu. Is it there?
Yes, sir. Mr. Sir.
Oh, I've sent something to your mail. Can you please forward that drawing to the group? I just want to I'm using this drawing to calculate cable for us. We might not see that being designed that way, but I'll just tell you on how to go about it. So let me just try and project the drawing. Check your mailbox. I've sent a particular drawing there. So let's look into it. This drawing, you must be very I still have a meeting by 9 p.m. So I just want us to have an idea of what are we there? Open to page. Let's open to page. Okay. I'm looking at where the page is. There you go. Sorry, I'm trying to look for the actual page. Yes. Open to page 32. Page 32. Are we there? Are we on page 32?
Yes, sir.
Now, you can see that this drawing is not having transformer, yes or no? Is it having transformer? No. Is it having?
It is not having.
It's not having that. So put it in mind that sometimes it might not be having transformer, but I just want to use this thing to explain some things to us. Now, you know, this our cable is coming from where? Our high tension bar, Abi, and
Yes, sir.
your pole has a standard height. Your pole has a standard height. What is the height of a pole? Please, we are all recording. We are all taking this measurement together. I don't have a measurement. What I just want to teach us here is just calculation on the cable. We've already done the major parts at the bottom. I just want to take us through how this cable is being calculated. So, what is the height of your pole? And someone tell us the height of our pole. Can someone tell us the height of our pole? Can someone tell us the height of our pole? Hello, are we there? Can someone tell us the height of a standard pole? QS Lekon.
It's around 9 meters.
Eh?
Around 9 meters.
We have 33 feet and we have 40 feet. Is it 33 or 30 feet? Now, let's do. I'm coming. Made vertical QS. This is the material used. So we are using 40 feet height. 40 feet is what? 12 meters, ba? Yes or no?
Yes, sir. Yes, sir.
Now.
Yes, sir.
No,
Oh yeah.
12 30, that is 36. It's not up to 14. 36.
What? 40 feet.
So 30 feet. 40 feet is more than 12.
Oh yeah. 1 feet is how many mm? One feet is how many mm now? Tell us.
1 feet is 300 mm.
God bless you. So 10 mm times 40 is what? Oh yeah, now 200 mm times 40 is what? Tell us now. Oh yes, so for one now.
That is 120.
120 divided by 1000 is what?
Oh, 300 mm multiplied by 40, that is 12,000. Dividing it by
12,000
1,000,
mm.
that's 12
Yeah,
meters.
12 meters. God bless. So,
Yeah, 12 meters.
So there's no carbon in this one. So now, let's do small measurements. Now, have you recorded 12 meters?
Yes, sir.
Now, 12 meters. Now, you can see that your cable will be connected, Abi, to your high tension, and there must be a termination, yes or no? Am I talking to QS? Are we there?
Yes, sir.
We are not there. I said, when your cable, we've measured 12 meters. Now, there must be a termination. Termination means there must be an extra cable for the connection of your cable to your high tension. Yes or no?
Yes, sir.
Now, we allow for 2 meters in that area. Making how many meters?
40 meters, sir.
14 meters. Now, you know that your cable will never be run. Your cable can be run in two ways. either surface on the way if I just keep it fine, did I go and attend my meeting?
We have it
Well,
with you, sir. We have it with you,
Well,
sir.
with you, sir.
If I not
I'm
respond.
with you, sir.
Now, I said your cable can be
Yes, sir.
can be laid in two ways, either surface on the air or what, or underground. But this cable will never be laid on the surface. Surface means whereby you use your cable tray, or you call it cable ladder. If it is being laid on the wall, they call it cable ladder. But if it is on the floor, they call it cable tray, whereby you have your cable jointer and the like. But when we get to that one, we will talk about it. Now, this your cable is going inside the ground. How many meter excavation can we do for it? Anybody?
800, 900 mm.
800, 900 mm. Any other person? Actually, you can do 800
600 mm.
We can't do 600. Why is that? If they are doing your compound level, what if your surveyor said go down by 600? You know that your cable is already being exposed. You know that. So me,
I said 1 meter.
so I usually allow for 1 meter. Abi now we are having what? 14, 15 meter. But Abi now let's now go back to this area. Now you now go back to your external drawing. Your external drawing, you now want to measure how the cable is being run inside the building. Do you see my screen?
Yes, sir.
See my screen now?
Yes, sir.
Now, I'm using cable. I'm using apartment A. Do you see? Do you see where they wrote to generator 3?
Yes, sir.
Okay, now. Okay. Now you can see the drawing I sent to you. The picture I sent to you in the group. The picture that your Oga sent. Do you see it?
Yes,
Are we
sir.
there?
Yes, sir.
What's the meter that is there? What's the meter that is there? Look at the picture being sent to the group. What's the meter that is there? Should I go? So should I close up? And
Please, sorry, sir. Which page are you so that we can just check from here?
You didn't check the group. There's a particular. I'm on page 5 of the drawing. Did Mr. Jami send it to the OT? He has everyone sent it to the group. The drawing here. Open it to page 5. Now there's a particular screenshot. What's the total length there? Someone is mentioning 19 point something. Oh yeah, speak up, Jerry. You know they with us.
19.46 meter.
19.46 meter. That is to say, from this point here. From this point, can you see my screen? From this point,
Yes, sir.
From this point to this point is what? 19 what? 19.46. Abi?
Yes,
Yes,
sir.
19.446.
19.46. Now, there's something called a tear off. You can see that the cable goes into the building. If you look at the grid line here, can you see it? Can you see this place now? You can see that the cable tear off into that staircase area. Do you see it?
Yes, sir.
Yes, sir. Yes, sir. We can see.
Now, your tear off sometimes is between 1 meter to 2 meters into that staircase. Now, remember one thing, that your cable is coming out of your, we excavated by 1 meter now, and our cable runs by 19.5. So your cable is coming out of the ground. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Now, we said it's coming out of the ground by 1 meter, and it is tearing off into the building. Let me see what I measured there. What is being measured? It's tearing off by 1 meter.
3.05.
Eh?
3.05.
No, that one is from the wall. That one is from the wall into in. Are you there with me? Now, it shoot out of the ground by 1 meter, and it tear off into the building by what? 1 meter. Now, what is the thickness of your wall now?
2.5.
Blessing, please, your background is making us. What is the thickness of your wall? Of your block work?
2 to 5.
2 to 5.
God bless you. So we keep for what? 0.23 or 0.2225. Now, you know that we've not know where our panel is, the location of our panel. Actually, now Mumu designed this thing. It's supposed to show us. Now, let's now go to where there's a particular place they now show your panel. Where exactly your panel is. You know that we are measuring 4 by 35 mm PVC SWA PVC SWA PVC based on the drawing here. Now let's go to where they now position our what? Our panel. Let's go to, hold on. Hold on. Open to page 9. Open to page 9. Let's open to page 9. Are we there?
Yes.
Now, let's open to bed. You can see where they locate our panel. Check your staircase area. Do we check our own staircase area?
Yes, sir.
You can see that we have MDB inverter on ground floor. Can see where they wrote MDB ground floor. Can see where they wrote COS ground floor. You can see where they wrote MFS ground floor.
Yes, sir.
Yes, sir.
God bless you. Now we want to locate where our panel is, Abi, based on our income now. But remember that this drawing is not having a panel. Look at this schematic drawing. They say from the metering to your gas switch, and enter what? your DB. They said 100 amps TPA 4-way main. So let's look for MDB now. But before we look for MDB now, your this our 4 mm by 35 mm core cable stops where we have our changeover switch, which is COS. Are we there? Now let's go back to page. Let's go back to page where we saw our panel being located. Do you see where they wrote COS and MD, COS, MFS? Let me try and project. Let me try and open this drawing in another area. So that's page 32. Do you see where they wrote, okay, our metering system? You know that mostly our meter is not usually being inside the building. Yes or no?
Yes.
Most of the meter
Yes.
installed is usually being outside. But in this case now, I will put down my metering system at that staircase area because of what? Number one, aesthetics. And because of what? I can't just put a metering system here and my wire. So let's just put our metering system here. MFS. So now it goes inside my metering system. What's the height of my building? At what height is usually my metering system being installed? You know, now we started our cable from the high tension from the pole. Pole is 12 meter, termination 2 meter. It enters inside the ground by 1 meter. It runs from that excavation to the building by 19.46. It tear off by 1 meter, shoot out by 1 meter, and we consider the block work. Now you know that this your, how will I call it? This our meter can never be placed on the floor. It will be placed at the height of what? 2.4 meter. So we put 2.4 meter. That's for the metering. Are you there with me? Where they wrote MFS, MFSG. Are you there?
Yes, sir.
Now, if you look at that page 32, you can see that from that our metering system, it enters our changeover switch where they wrote COS, Abi?
Yes, sir.
COSG. Now, the distance of our metering system to our changeover switch, like how many meters can we allow for? Hello, are we there?
Hello, sir.
Hello.
Hello, sir.
Yes. I'm there with you.
I think we should probably allow maybe like 3 meters.
Yeah, 3 meter care. Even the staircase is not even up to 3 meter. From this guest room to this thing is not even up to 3 meter when I measure it.
No, it's like that.
So it's just now. Can you allow your metering and your changeover? It's usually beside each other. Sometimes it's not even up to 400 mm, but let's allow for 0.6 meter. Are you there with me? Are you there?
Yes, sir.
Yes, sir.
Now, This MDB is what? Main distribution board, yes or no?
Yes, sir.
Yes.
This main distribution board is not like a normal DB that we erect inside the building or inside the wall. You understand what I mean? This main distribution board is like a panel also, but it is not like that one I showed you inside that inside the picture that Mr. Jamiu projected. Do you understand what I mean? It's like a DB, but that DB is very big, and it is not like the main distribution board. Now, that DB will now be on the floor. You know, you've already connected now. Now, remember that from that changeover switch, now your cable will change. Let's remember your cable is changing now. Remember one thing, that we started with what? 4 mm, 4 core by 35 mm now. But now it's now changing to 5 by. Now, what is the total length of our cable now? Can someone tell us how we picked it? Or I should tell us how we have been picking it since morning. Can someone jot it for us? Is someone there? Because that person will be the one to snap it into the to the group. Are we there? Okay. Jemima.
I'm with you, sir.
Now, you know that we say the height of our pole is what? How many meters? 12 meters, Abi?
12 meters, yes, sir.
Now, write 12 meters, height of the pole. Now, you know that I said we will allow for 2 meters for what? Termination, Abi. Write 2 meters.
12 meters.
Termination of cable to the high tension. Yes or no? Now,
Yes.
now we now said that we must excavate because our cable will not be laid on the floor. It will be laid inside the trenches. We allow for 1 meter excavation. Abi now. Now,
Yes, sir.
we now measure from the pole to the building. We get 19.46. That's pole to the building, 19.46. Are we noting it down? 19.46.
Yes, sir.
From the high tension pole to the building. Are we there with me? Now,
Yes, sir.
and I said, you know that your cable will come out of the ground floor. I said, you know, our excavation is 1 meter. So you now say 1 meter, shoot out of the ground by 1 meter. It will not tear up into the building. Tearing up into the building by 1 meter plus your 0.23 because of the wall. Are you there? Are we noting it down? Now,
Yes, sir. Yes, sir.
we now
Yes, sir.
said our meter is at a height of 2.4. It's so that your cable will now rise up to where your meter is by what? 2.4. Yes or no?
Yes, sir.
Eh?
Yes, sir.
Now, from that our meter now, you now connect from your meter to your changeover switch. We allow for 0.6 meter. Are we there? That's
Yes,
from
sir.
the metering to the what? Changeover. So, can we get the total? Can we get the total? Can someone tell us the total? Can someone tell us the total? Can someone tell us the total? What is the total length? We are calculating 4 core by 35 mm. PVC, SWA, PVC. Can someone tell us the total? Someone will send
Yes,
this
sir.
thing to us. Mr. Jami,
Sir?
you know that we are calculating cable, and I was specifying how it's being picked. You know, I was telling you, so are we taking note of it? So you now put what was the total length of the cable at the end of the day?
38.73, sir.
38.73. God bless you. Are you going to leave that 38.73 like that?
No, sir, we are going to multiply it by 4.
No. We are not multiplying by 4. That 4 is 4 core, not 4 runs. Remember, I was telling you that you know that they wrote 4 by 1 core by 35 mm. Activin is being wrote. So if it is to 4 by 1 core by 35 mm, it shows that it is 1 core multiplied by 4. But they already wrote 4 by 35. So it is a 4 core cable, not a single core cable. Put that one into confusion. Now we have total length as what?
38.73.
Are you going to leave that 38.73 like that in your B? What are you going to turn it to? What will now be your final answer?
39.
39. So are you going to put 39 in your drawing?
Sorry, I don't get it, sir.
I said, are you going to put 39 meter in your bill of quantity?
Are we going to be dividing that value by 4?
You are not dividing that value by 4. That's the total length. We've already have 4 core. It is 4 core. You are not dividing it by 4. Are you going to put that 39 meter in your bill? Can someone tell me why we should not put why? Are we going to put 39 meter in that bill, or we add something to it?
Sir, I think we should.
I think we probably add
allow
small
for
space
connection.
for stage and others. Wastage and cutting off.
I think we add something to it, sir.
God bless you. You must add slack to it. Do you know the reason why we want to add slack to it? Ask me why.
Why?
You know,
Why?
you can get to site now, and the engineer that designed that thing will tell you that we're supposed to pass now. He's like, that place will not work again. Let's pass to this side. Are you going to go and meet your client that that 39 meter cable cannot reach again? So yeah, we use extra 4 meter to it. Come and pay. Do you understand what I mean? There might be rerouting on site. There's difference between drawing and there's difference between execution. You might get to site, the person executing will tell you that I'm not passing through the ground again. I want to pass through the slab. Are you getting me? You know, there might be addition. So you now allow for 10%. 10% for slack. That's 10% of 3.9 is what? 39 is what? That's about 3.9 meter. Approximately 4 meter. Are you there with me?
Yes, sir.
And just trying to give you it because I know that you people will just put at 9. But in practice, you will allow for extra. Are you getting me? You will allow for extra. 18 email. You have 2 years. So now, if you look at that page 32, from our changeover switch to your main distribution board, cable has changed. Do you know that? Let me show it to you. Different change cable. Do you see it? From the changeover. From the changeover to the panel, what do you see? From the changeover to the panel, what do you see?
5 by 35 square PVC by PVC copper cable.
God bless you. You know that your changeover is at the height of what? 2.4 abi now, and your distribution board is on the floor, but yes or no?
Yes.
Now, you know, now from that your changeover now, we allow 0.6 for termination. What's the height of your changeover to the ground? Is 2.4. Are we writing all this thing down? I'm not repeating myself. Oh. It is what I'm writing down. It is what I'm dictating for you. Is what one of you will send to the group. From the meter, no changeover, you allow for 0.6 termination. Now, height of that your changeover to where your DB is on the ground is what? 2.4. Now, we will not allow for 1 meter termination to your DB. That DB might be connected in 2 ways. Are you there with me? That DB might be connected inside the wall beside your changeover at the same height. That your DB might be connected on the floor. That they just screw it on the slab. So it's 2 ways. So for us to be on safer side, I'm saying my DB is connected on the floor. Are you there with me? But if at the later on is now being connected beside that changeover, we are on safer side. What if we now say, okay, it will be beside the changeover, and at the end of the day, the person is there putting that project say no, it will be on the floor. You know that we are already shortage of cable. Are you there?
Yes, sir.
Now we now have 4 meter for 5 core by 35 cable. Are we catching up with my explanation?
Yes, sir.
Are we following with my explanation?
Yes, sir.
Now, you can see that from this changeover to your generator, we are using which cable? Let's look at the layout now. Let's open to now. We want to know the distance of our cable. We want to know the distance of our cable from generator to your changeover. Are we getting my explanation? Now, do you see my drawing now? Do you see generator 3? Can we see generator 3? Now,
Yes,
what
sir.
is the distance of that generator to the building? We are still using 4 core by 35. Now, remember, note something. That markup we did, don't do markup yet, because this generator stated that we are using 4 core by 35 also. Now, what is the distance between this generator to this wall? Are we there? What is the distance between this generator to the wall? I calibrated 10.44. Can you see that picture in the group?
Yes, sir.
Now, you know that we are going to let's start from the generator. Your generator now, I'm allowing 2 meters for termination because there will be waste of cable there. Yeah. 2 meters for termination. Be noting it down now. Excavation will receive 1 meter. From that 1 meter to the building, we measure 10.44. If you look at the screenshot being sent to you. Now, your cable shoot out of your ground floor by 1 meter. Tear off into the building by 1 meter plus 0.23. Yes or no? Are we there? Are we there?
We are not there.
You are not there, boo. Be there. Explanation has been given. I said from your generator, termination of your cable from your generator is 2 meters. Now, you will excavate by 1 meter. That's extra 1 meter for the cable. Now, from that generator to the building, we measure 10.44. Go look at the screenshot I saw Mr. Jami sent to the group. Now, it will not shoot out of the ground floor by 1 meter. Tear into the building by 1 meter plus 0.23. Are we recording all these things? After that, the height of your changeover. Are you there with me? Remember that your changeover is beside your metering. So we just allow for 1.5 meter extension to where your changeover is. 1.5 for let's just say 2 meter extension. I'm not assuming, but we just need to be safe. Now, 2 meter extension. Now, your cable will now run up to where your changeover is by 2.4. Allow for 0.6 meter termination. What is the total, Madam Grace?
Sorry, sir. You said height of the changeover, that's the extension is 2 meters. And termination is now 0.6.
Auntie, extension means as the cable enter inside the building now, at that corner of your staircase, it have an extension. It's just like your changeover is not beside the wall, is beside the changeover. Now, the distance between that your wall to where your changeover is, we allow 2 meters. Now, we now say extension is 2 meters. Projection to where your changeover is 2.4, and termination by 600 mm. Do you understand me?
Yes, sir.
Please, what is the total? Our 4 by 35 mm cable, we have 39 meters. Now, give us the total meter of this one. What is the total, please? I think our vice president is online. You are welcome. So, what is the total, please? Everybody just keep quiet, expecting one person to say the answer.
Sir, okay, sir, that's 2 meters plus another 2.4. That's 4.4 plus another 0.6. That's 5 meters. Then plus 39, Abby. 39.
Auntie,
That's 44 meters.
Auntie,
Sir? Sir, I'm listening,
I
sir.
was explaining this cable
network.
from generator. You are telling me 2.4 or 0.6 meter. Fine. What about the cable that runs from the generator into the building? Answer me now.
Hello, sir.
I'm listening. It's like the way I'm just shouting, everybody just keep quiet. Maybe you should just call it a day and let's just end the class there. And I know that next
Hello, sir. My calculator was 24.67.
What do you say?
I got 24.67 with the addition of 39. This thing would be 63.67.
Why is it that it is until when someone start shouting, that's when some people will now leave? It shows that some of us are just listening and just okay, let me just be online and they should not remove me from the book. We are not participating. It is fine. So what was the total, please?
63.67.
Now that 63.67 you not allow for slack, which is 10%. What was your 10%? That's 6.3. So roughly is around 70 meters. Are you there?
Yes, sir.
Do you get my explanation?
Yes, sir.
So that sometimes whereby they won't show you that. They won't show you this type of. Let me explain something to you. They won't show you that this polo. They will just show you that from 11 kVA power line. Do you know that? They won't show you these details. Showing this pole. So you understand, sir?
Yes, sir.
Now, I came from the what? From the high tension till you get inside your building. Same step. Are we there? Same step will be followed when we are calculating all other cable. That sometimes whereby you be seeing different cable, like the drawing we used yesterday. Do you understand? Look at this drawing we used yesterday. Look at this drawing we used yesterday. Look at this drawing. Do you see this drawing? Do you see this drawing? See what they wrote.
I can't see anything.
Let's start from cable number 6. You can't see anything. Can anyone see my screen?
You can see it now, sir.
Yes, so that now you can see that they said 11 kVA NEPA supply from the nearest PACL. You can see that they did provide us that 3D. Do you remember? They did provide us that 3D. Then that shows us that is coming. Now you not be the one to now sit down to analyze it the way I analyze it that time. Are you there with me? You can see what they do. They say 4 numbers. Remember, I was saying that this 4 number is not 4 call. 4 number, 4 in 4 places. We have 25 mm by 1 core in 4 places. It shows that we have 4 runs. Are you there with me? Now you now measure with the way we measure.
Yes, sir.
Oh, height of your pole, 12 meters. By what? by remember by what? How will I call it? By dimension of 2 meter inside the ground 1 meter. You now measure. See, when you are measuring, you must check something called your site layout. Look at this site layout. It is your site layout that you can see my site layout here. You can see where they wrote number 1. You can see that. You can see these are number 1, high tension into the transformer. From this transformer, they now tell us that our next cable is what? Is running from transformer to where? Is running from transformer to where? Is running from transformer. Is running from transformer. Is running from transformer. On this distribution schedule. You can see that is running from transformer to where? To your 400 amps enclosure, and we are using cable number 1. Are you there with me? Do it. There and look. From your meter, it enter your panel. Are you there with me? Still using number 1 cable. Put that one aside. Now, from that your panel, you have a changeover. You have to generator. They use 1 From there, your changeover. So as your cable is going, as the number is being mentioned, you will check your site layout with your drawing. You now be looking, okay, from this place to this place. You now be using your blank script. You now be calibrating. Okay, it enters this jar switch. Okay, what's the height? Are you putting the jar switch on the floor or on the height? Put it there. Termination. From there, it goes again. Are you there with me? Are you getting my explanation? Are you getting my explanation? Do you get my explanation of calculation of your cable?
Yes, sir.
Yes, sir.
God bless you. So we are done with high tension cable and the low tension cable. So it is what you see, you now be following. How is being laid on the plan? Okay, shoot out, allow for it, termination, this and the likes. Then we now go by it. So any other question? Any other question, please?
No, sir.
So any question? Do you grab what I explained yesterday and today? Do we grab them?
Yes, sir.
Yes, sir.
Okay, we got it back. So if there's no other question, can we just call it a day?
Yes, sir.
Any other question? Any other question?
I'm sorry. If you're on the call and you have not filled attendance, please can you ensure you do? It's about to close. Thank you.
Okay, so if there's no other question, it shows that we all understood the drawing and we all understood the explanation. So this time next week, we'll be moving to the earthing system, lighting arrestor, and maybe substation. No, I'm looking about substation. So after our earthing system, that will be done for a class. The following day, we now do our normal counting and okay, our lightning fittings and calculate for our final circuit. So next week we now talk next week we now talk about solar system. We'll be talking about your solar panel, your inverter battery, and so on and so forth. So after that, we end electrical and move to transportation. Transportation we take just only one class. On transportation, we move to mechanical, where we'll be talking about HVAC and AHU. From there, we move to plumbing. So if there's no question, can we just call it a day? So if there are no questions, I rest my case here.
Thank you, teacher.
Thank you very
Yeah,
much, sir.
thank you, Mike.